Today's episode is going to resonate with anyone responsible for uptime, efficiency, and ultimately product reliability. Because whether we're talking about circuit assemblies, manufacturing lines, or entire facilities, reliability doesn't start at inspection. It starts with maintenance. Welcome, or hopefully welcome back to the Reliability Matters podcast. My guest today is Paul Ross, Chief Marketing Officer at Limble, a company providing modern maintenance and asset management solutions to thousands of organizations worldwide. With more than 25 years of experience in enterprise and high-growth software companies, Paul has spent his career helping organizations leverage data, systems, and strategy to improve performance. Today, we're going to explore how maintenance has evolved from a reactive necessity to a strategic driver of reliability, what companies are still getting wrong, and how modern tools are changing the game. And it all begins right now. Stick around.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Paul Ross, thanks for being here today. I'm really looking forward to our conversation.
Thanks, Mike. I'm really excited to be here.
Well, let's get started, shall we? And when we get started, let's start at a high level. When you look across the organizations Limble serves, what are the most common maintenance-related issues that directly impact reliability?
Well, it's interesting. Like what we see is that most organizations don't necessarily have a reliability engineering problem. They have really smart people who are doing the job, and they're putting things in place and understanding what's going on. They really have often have a maintenance, execution, and data opportunity to improve what they're doing. I think that if you look across organizations, and we as you said, we kind of serve thousands of organizations, including a large number of electronics manufacturers. These teams have strong technical knowledge. They have an understanding of how equipment should run. They have a vision for what reliability looks like. The opportunity is in them in how they execute their maintenance work consistently. That they capture the data that then becomes part of the reliability engineering process, and kind of scaling the knowledge about how to maintain that and do that across the organization. So I think, like, if you look at how maintenance kind of impacts reliability, the biggest opportunity we see is organizations moving from a very reactive state. So break fix, seeing that there's something that's underperforming and doing maintenance on it, to becoming more proactive in their processes. So doing preventative maintenance rather than kind of reacting. Like one good example is a customer we might talk more about is Emerson, who I'm sure you're familiar with.
Sure.
Global manufacturer of precision equipment. For them, reliability is like mission critical. And their equipment has to be perfectly calibrated and consistently maintained. And it's that consistency of maintenance that's important here. And that's what they focused on, is that they focused on creating consistency across all of their sites, standardizing how maintenance work gets done, and then using the data that gets generated there to improve visibility in terms of asset management and ensuring reliability is consistent across the organization. So I think really ultimately this is an opportunity to, how do we get more reliable maintenance done, doing preventative, moving through a kind of a maturity curve there that generates data that can be used across the organization.
Yeah, no one ever says we're going to do some RM today, reactive maintenance.
That's right. But they are.
But they are, yeah. But there's not even an acronym dedicated for reactive maintenance. It's
That's
PM
right, yeah.
reactively.
So we created one for preventative, and then hoped everybody would be good and just anchor onto that.
Yeah, exactly. Tell me a little bit more about Limble. How did Limble come to be? What types of companies use your services? What type of services do you provide? This is not a commercial show, but I do want to frame.
No, I'll give you
I do want to frame the foundation of this entire conversation today based on your professional career and what Limble is on this planet to do.
That's great. Yeah, I totally agree with you. Like, I think I'm more excited to talk about customers than I am about us. But to give you the context for us, so we're a kind of modern maintenance and asset management platform. And there's a couple of things that some of your listeners might be familiar with in terms of, you were talking about acronyms. We're an industry that loves acronyms. The CMMS market, the computerized maintenance management system market, and the EAM, enterprise asset management software, which is often attached to kind of ERPs and that kind of capability. So lots of acronyms there. But ultimately what this is about is that our reason for being is to help organizations and empower the people who manage and keep all of the assets running across industries. As you were mentioning, we do provide those services to a lot of industries, so facilities teams, so large sports teams, large entertainment venues, casinos, hotels, all of those people use it because they are doing maintenance and they're managing assets in the same way as manufacturing companies.
I'll bet casinos are doing a lot of preventative maintenance because downtime to a casino, while no one dies, certainly their bank accounts die, right? So
that's right. It's actually a good analogy with a manufacturing production line. Is that every hour, every day that something is down impacts the production. In the casino's case, cash, but in the production of product has a material impact on the outcome of that business. And so that's why we exist. Is how do we help people maintain that uptime, improve uptime, but then also be able to make decisions across assets as well. You think about Emerson; they're going to have thousands of different assets in their production facilities, in their HVAC, in all of these things that make sure that they can deliver. When do you make decisions about investing in a new part of that production line? When do you put in place a new circuit production path that enables that organization to get the most from their production? So all of those types of things are where we help. As you mentioned, we've got about 3,500 customers. It's split across manufacturing is our number one set of customers that we support. And then large facilities is the different one. And there's obviously a lot of different detail around electronics manufacturers, discrete, et cetera. So a broad selection, highly focused on the manufacturing business.
Yeah, I was giving a entrepreneur talk. I talk on two different things. I talk my boring stuff and my exciting stuff. Boring stuff is going way down technical rabbit holes, for electronics manufacturing. And although fascinating to me, boring for all my friends. And then I do some entrepreneur talks. And I was doing an entrepreneur talk and about innovations, major milestone innovations, people who were not entrepreneurs but had an entrepreneurial spirit on a production line, right? They were line workers. And one of the examples I gave was Toyota, how Toyota many years ago empowered all of their production line workers on an assembly line. Any one of them on that line could shut the line down. They had a name for it, and people who know this are going to go, "You got it wrong, Mike." But I think it was like the andon cord system. So basically, it was they could pull a cord or they could do something, and they had the power to shut the line down, and it was to be done, obviously only for like dire emergencies, but any person could do it. And at that time, Toyota was producing one car every 60 seconds, and I think they got it down to 40 seconds now. But we'll go one car a minute. The average wholesale value of that car to Toyota was $43,000. So that was $43,000 a minute for every minute the line was down. If that cord ever got pulled and the line shut down, they fixed the problem. And while they were at it, they looked at anything else that might cause that cord to be pulled again, right? So to your point, that's a really good example, $43,000 a minute of it's cheaper to do maintenance. I was just at the Tesla Gigafactory in Austin, Texas a few weeks ago. Oh my God, totally. No matter what anyone in the audience thinks of Elon Musk, it's undeniable the amount of engineering he put into that factory. It's absolutely mind-boggling. 11 million square feet under one building. The building's a mile by half a mile wide. But at any rate, we went on a Friday. They don't do any production on Fridays. They produce cars 4 days a week. And 90% of the car, the Model Y that they were building there, is done autonomously. It's done with robots. And so Friday is maintenance day. They have an entire production day every week, every 7 days. They shut down that factory, and all they do is maintain things. They have 12,000 workers in a largely lights out factory, and a lot of them are there to maintain the equipment. So I mean, that tells me the $43,000 a minute, lands on them too, right? So they tend to do a lot of maintenance. But anyway, I digress.
It's a really good example, though. It's like to be honest with you, more than anything else, to me, that's about mindset around this. There's clearly, like, we're a technology vendor. We would like people to buy software. People should buy software. It's good, but it's actually mostly about the process and consistency of that's important. Right. If you look at, I was at a very small, in comparison to Emerson or Tesla, manufacturing facility recently where they produce the batteries for kind of warehouse machinery. So you think about the very large batteries that are essentially the weights that offset how they move equipment around, and they're printing circuits for those batteries to drive the forklifts and all of those sorts of things. They are in exactly the same situation as Tesla, like maybe nowhere near as expensive per minute of downtime as Tesla or Toyota, but that's still a line that's down because they're printing, circuit printing equipment is down, and therefore they're not getting there. And they are a great example of maybe that costs them a couple of $100,000 a day in downtime.
Yeah.
But that's still hugely impactful for them. But it's that they took that same approach of, we need to make sure that we're shifting from this reactive mode into preventative mode for two reasons. One was because it will make sure that we have less downtime. It was very clearly measured. And I think the assessment of, like, how do we justify this investment in maintenance comes from having that data about what the impact of being down is. But then they're also being able to track the life of that equipment, being able to make sure that they have the attitude that we need to get the data out of this in order for us to make it clear that we need to buy a new version of that equipment at the right time. So I think more than anything else, what that story tells me about is the importance of having the right attitude and the right processes versus just having another piece of technology to drive it.
Yeah, I agree. From your perspective, how does poor maintenance translate into real-world failures in manufacturing environments? I'm sure you've got a library of case history stories there, right?
We have a lot, I think the biggest thing is, like, when we talk to our prospective customers for the first time, when they come to us, or we reach out to them, the starting point for those conversations is almost always that they are spending about 70% of their time being reactive. And then when we actually drill into what that looks like, is that they have equipment that's failing at a rate that's far beyond what their procurement teams, their kind of reliability engineering teams are kind of forecasting, because they're not able to get ahead of that maintenance. So it seems like such a small thing of, like, greasing a bearing, such a small thing. But if you're working with a robot production line and the arms are starting to fail because of that, that's slowing you down. So I think that's the first thing, is we see a huge amount of kind of reactive maintenance occurring. We also see people, to be honest with you, even at the larger organizational sizes, where they're running all of this using spreadsheets and paper and tribal knowledge. Those are the things that kind of drive things. And one of the key things to emphasize here is that this work's getting done. These are people who are every day putting sweat into and commitment to making sure that these production lines stay up and running. But it's when you have it's a systematic failure often that's the cause of this downtime, not the people. That's a really big thing about it. The second challenge is that without this data being captured around how often we're maintaining things, are we hitting our preventative maintenance schedule? Are we doing those things? Are we understanding how frequently we're replacing parts? All of that data not getting captured in the maintenance team, it means that hundreds of thousands of dollars are being wasted in procurement or not being added to budgets to make sure that their production is up and running. So it's both a kind of a tactical issue and a strategic issue for the organization.
What do you think are the hidden costs of inadequate maintenance that leadership overlooks? I can argue both ways. I can say reliability begins at the bottom, works its way to the top. I can say that it starts at the top, works its way to the bottom. It's probably a little bit of both. But what do leaders of companies just, get wrong? And what are the hidden costs they're not seeing that maybe the people down on the production floor do see?
Yeah, I think it's a really good point. The first of which is most of the systems to understand how the organization and how the production lines are actually performing are built top down. So all of that, the idea of like using an ERP allows you to see a dashboard of the health of your production line, your production capacity. All of those things are built with those senior leaders in mind, which is great because it's important kind of for them to have visibility. The challenge is that what that means is that none of the information is getting into the system for them to be able to get access to that visibility. I think that the lack of understanding of a couple of things. One is how much money do you invest in your maintenance program? That's a key thing that it often gets lost because of this idea. Is that I was at SMRP. You might be familiar with that conference, which is the Maintenance and Reliability Conference. A large number of manufacturers there, and there was a session there where they were talking about, but I don't have the data to justify my maintenance team training. I'm losing my people because they're retiring. How do I justify like bringing in new people to do that, to work alongside them? That is like when you don't have visibility in terms of the impact of not doing a maintenance program and not capturing the data, those decisions go wrong. So I think that's one of the first things. And then it's just literally that people aren't able to understand why production is being halted because of a piece of machinery going out. They just don't understand. It's impossible to judge because you're now just going and, oh, that thing went down, we need to fix it. So that's often where the things are
their sole motivation might be, at least in the moment, which is kind of fair, is get it back up, right? Yeah. But then once things are running again, a lot of times you're just going to the next fire, and the next fire and the next fire, and it's like when. For nervous flyers, when it's really turbulent, people are making deals with God. They're going to change their life. They're not going to swear anymore. They're going to, feed the homeless. And then the plane lands, and then next thing you know, they're driving past all the things that they said they were going to do. I think the same as
we'll invest in our training. We'll invest in our training. Sure, we will.
Someday we're going to fix that. Yeah. How's the role of maintenance changed over the past decade with the introduction of digital tools, hence your company, and data-driven systems?
Well, I think that there's some really interesting aspects of this. Is that the core of everything still remains the maintenance managers and the maintenance techs on the front line, with wrenches, doing the things that they need to do to get things done. So that still remains the same. I think the key thing is there's really kind of, I guess, three big things that I would highlight. One is we've seen a change in understanding of how miserable the job of somebody in maintenance has been if all they're doing is reacting to fires. Not literal fires, hopefully, but fires. And they're just doing firefighting. And they're just constantly moving from one crisis to the next. They're dealing with those things. We've seen a real challenge in terms of recruitment and retention because of that. And so what we've seen is now that we're moving firstly to this new kind of model, moving up the maturity model from reactive to preventative, and even starting to look at, especially in electronics, we're more condition-based maintenance, so using sensors. Those people are now able to be ahead of things. They're able to get ahead of those things. So the quality of their life goes up immeasurably. they're getting home on time. They're not having to react to so many kind of fires over the weekend, firefighting over the weekend. So I think that's the first thing that we've seen, that the introduction of these tools has made a huge difference. The second thing is that the people in leadership, so plant managers, production managers, reliability engineers, now have data that wasn't available to them in the past, or that they were having to really scramble to get access to. Like the SMRP conference, they were talking a lot about how do you justify your maintenance investments, or how do you justify changing the processes in a particular plant, because we can't get Jim, the plant manager, there. He's old school. He won't do these things if you don't have the data to be able to show the impact of what your program looks like, or what the changes look like. And so I think the digitization of the process of introducing preventative maintenance, running a maintenance program, making sure that data is there, has a huge impact upstream overall. And then the third thing I would say is that we've seen a difference in is the kind of strategic investments that are being made, or the way that people are using software and systems to make some of these bigger strategic decisions about, you're talking millions, if not tens of millions, for some of the equipment that we're talking about in terms of an investment. The data that's now available to make those decisions about when we need to switch vendors potentially. We have a great example of a customer who had looked across just to simple their HVAC systems in their manufacturing plant. A lot of these manufacturing plants that we work with are in Texas and Arizona and places like that, where it gets very, very hot.
Yeah.
And so if your HVAC system goes down, that's actually a production machine in essence, because you can't work.
Sure.
So comparing across the different HVAC systems to see which ones were breaking down more frequently, that parts were failing on, all of that data is suddenly available. So you've got this really interesting, longer term decision making that you can start to make, that the people who we're empowering are now able to do that they weren't able to do before.
Both your industry and my industry love our acronyms. We embrace acronyms. Can you explain how a modern CMMS system, computerized maintenance management system platform, improves reliability compared to traditional maintenance approations?
Yeah,
it's a new era now, right? You talked about an example of someone's old school. So contrast the difference between old school and new school.
Yeah. Well, I think the interesting thing in this conversation is that you're often it's kind of seen as old school people and you're younger people. It's not actually true. There's we've got multiple generations of people in the workforce.
Sure.
It is incredibly important that we have a system that is usable by a technician on the front lines, that is simple, easy, and does the things that they need to do in a structured way, so that they're not having to do it. So there's a big part of this is just that you don't get rejected by those people. And that's not about them being old or more experienced, maybe. It's about the fact that that's I'm on the front lines. I'm in a hot manufacturing plant. We were at a glass manufacturing plant recently, the furnaces, just thinking about that. This thing needs to work there.
Yeah.
So that trend, the move from these very monolithic ERP type systems to solutions that work for the front lines. We just released a new version of our mobile app, which is what the technicians use. So instead of building something that was let's take all the features of our web platform and put it on a mobile device, we built a mobile app for technicians. And so that's a key thing in that transition that we've seen. But the biggest aspects of what difference it makes is that because it's easy to use, because it's aligns with the processes and the workflows that these people have, and it fits within their work, all this data is getting captured. So it's not just sitting in somebody's head. It's not just in a spreadsheet somewhere where a maintenance manager is asking Bill, "Hey, did you get to that thing? Did you do this stuff? Yes, you did. Okay, cool. We can work our way through that." So you get all the data in one place. It creates consistency of execution. If I go back to Emerson, their transition was not necessarily that people weren't doing good maintenance work on that highly calibrated machinery that we were talking about. It was that they were now able to get consistency across their plants of how that would work. And then when you're talking about these larger manufacturing with multiple plants, that really matters. You talked about Toyota, all of the Japanese approaches to manufacturing, where it was consistency, it was quality, all of those things. You can't do that unless you know what's actually happening. That's the second thing, I think. The third thing, and maybe this is data being trusted across the organization makes a huge difference. We did a survey recently that showed that where data wasn't being captured from the maintenance team about what they were working on, when they were doing their PMs, all of those things, that the trust in the data that was being used for decisions like procurement, like capital expenditure, like maintenance staffing investment, the trust in that data dropped to 4% if that wasn't being consistently captured. So you think about what that means is that, like, you're in procurement, I don't trust any of the data that's in our system to decide whether we're going to go buy a new piece of equipment. Wow. If it was captured consistently, that data went up well over 50%. Now, we don't like it to be 100%, but sure. Anyone who's worked in a larger organization knows the challenges with trusting data, but that's a 12x improvement.
Yeah.
So that's the last thing I think is like this idea of data being a trusted foundation across the organization.
You know, I'm in the electronics manufacturing space, and years ago, this is probably mid to late 1980s, one of our customers was a memory chip manufacturer in Southern California. Just the fact that building memory chips in Southern California, that tells you how long ago it was, because I don't think any of those are made in the U.S. anymore or anywhere in North America. But the funny thing is I could get into the factory, no problem. You know, you make an appointment, you just kind of walk through the door, do whatever you got to do. Coming out, we had to go through a metal detector, and they had armed guards on the exit. And the reason why was memory was so expensive. A little SIM card, or a little, not SIM card, a little card with 128 megabyte, not gigabyte, not terabyte, megabyte was, you know, $800 or something. And they're the size of, you know, they're 3 inches long. So they wanted to prevent visitors or employees even from, you know, grabbing a handful, putting it in their jacket pocket and walking out the door with a few $1,000s worth of material. So that's how expensive memory was. So back in those days, industry that did collect data was very selective on the data that they chose to collect because memory was expensive. You know, fast forward to today, although data centers and AI are driving up memory prices again, it's still cheap. It's still, you know, it's almost free. It's a rounding error, you know, on an accountant's spreadsheet, the cost of memory. So now we're collecting so much data. Now now there's a phrase, big data, right? So much data, humans can't parse it. It's just I mean, millions of data points now because it's almost free and we can. And every equipment manufacturer is, you know, we build equipment, we're collecting tons of data. Not sure what we want to do with it. We just want to know we have it. Well, if a customer wants to figure out a way to use it, great, it's all there. So how does your company, considering you're interfacing with a variety of machines you don't build, a variety of data collection strategies that you don't have a lot of input in, and a variety of legacy machines that might store data in different formats, and then now the sheer volume of data, how does a company like yours prioritize the hierarchy of that data and know which data is not important, which data is vitally important? Do you use do you bring in AI to help, you know, sort that? Is it all done through consulting with your clients? That seems like an enormous project that would require a ton of expertise. And it sounds like I'm preaching to the choir here. You're like, yeah, duh.
No, I think it's definitely like, you know, in a lot of cases, this software, and specifically how we focused ourselves on, is what we would describe as easy and quick to deploy.
Right.
But in order for you to get the maximum value from this, like all those things we were talking about, there does need to be some level of hierarchy and kind of thing built out to enable that. It's actually one of the reasons that we typically recommend our customers start with, let's get your PMs into the system. Let's get QR codes on the side of the machinery so that people can start a work order getting there, and that you're managing your maintenance team with our scheduling and all those things. That's actually a relatively straightforward thing to go do. That's a few days, to be quite frank. Maybe printing the QR codes and putting on machines might be a little bit longer, but that's the core of it's that. The second part of is your point's very, very important, which is the core of this is to think about it like, what's the most important thing for the customer and users that they're doing. And for us, what we found that to be is assets and asset hierarchies. So you take a plant, the location is the very top of the hierarchy. And then here's the one production line, or here's a component of what we're doing. And then you break it down further and further down that path. One of the reasons that we actually tend to be successful when we're up against some other vendors is that we try and make that hierarchy as flexible as possible. That comes with a cost, though, because you have to make sure that flexibility doesn't lead to complexity.
Right.
So
right. That's kind of where I'm going with this. It seems it could be like this is such a big project. I don't want to even start it. We'll just keep reacting instead of preventing.
Exactly.
And yet it probably is, when you work with companies who are experienced in this, like you guys are, you guys probably go, I got this. We've seen this 1,000 times before, right? So it's a mixture of both.
It is. It's definitely, and we tend to be work with people to be very thoughtful about that process of going, start here, do this, add this production line, or add this facility, add this, and do it that way. Because you think about like manufacturing is the home of the ERP.
Right.
And I don't know if you've personally been through it, but I've had a lot of experience of very large ERP implementations. $11 million.
It could take 3 years. Yeah, it takes 3 years, and you don't see your children and your friends for 3 years. Right.
And you're paying a lot of money to consultants.
A ton of them. Yeah.
So they're important. They play a hugely important role in the success of especially larger manufacturing. But the key is for us is not necessarily like if we're selling to someone like Emerson across multiple plants, we're not saying go everywhere. Go everywhere for the maintenance management, the work order processing side of things, and then roll out asset management to be able to go across the organization so that you're doing it. That tends to be the way that people are more successful in doing it. And then having somebody, this comes back to somebody driving this strategy at the organization, is when they've got access to data to be able to show the pattern, show what's happening in the organizations, that makes them a top performer in terms of the stuff. That makes them a thoughtful way of rolling this out. So it tends to start with work order and then asset management, and then that data starts to feed it, become a closed loop system for how they're doing things.
You use the word top performer. In your experience, what separates companies that are top performers, that excel at maintenance, from those that are maybe not top performers, those that struggle?
Yeah, it's a really good question. And I think the part of this is that even within an individual organization, many production plants have a lot of autonomy in how they operate. Now, there's kind of rules and things. I think in electronics, it's less so that way, but in many manufacturers, there's a degree. So I think it tends to be where we have clarity about what the workflows are supposed to be, like that we have the preventative maintenance actually mapped out. We know that what we're doing. And then they maintain consistent processes to deliver on that. So it goes back to that consistency discussion. And they're kind of focusing on making it easy to do the right thing. I think top teams make it easy for everyone to do the right thing, not just their most experienced people.
Yeah,
like that's where it is. It's like having those workflows, having those processes in place, and then making it easy for the people on the front lines to do their job and capture the data that they're looking at.
Yeah. When I think about preventative maintenance, the number one goal, the poster child of all goals comes to mind, is uptime. Don't stop the line.
Yep.
Keep the line moving. Production,
Yep.
efficiency, but it also falls on reliability. I think one thing that's even worse than a line down situation is a broken line that's not down. It's just producing parts that are not correct, that are out of spec, right? And it's not on off. It's not always a binary, line is working, line is not working, or line is producing, line is not producing. It may be producing incorrectly. And, since this show is called Reliability Matters, not Line Up Matters, I want to also bring in the consideration that proper maintenance, preventative maintenance, keeps parts coming out in tolerance, however that is defined in one's industry. In my world, the electronics manufacturing world, we have things like stencil printers, that print the solder paste onto the bare board. Then we have pick and place equipment that place the components onto the board. Then we have ovens that reflow the board and solder the components to the board, and inspection systems and cleaning systems and all these different things in an assembly line. Any one of which improper maintenance or no maintenance can affect the accuracy of all of those steps. So in addition to, avoiding the $43,000 a minute penalty that Toyota would have if they dropped just one production line, I think the costs are even more severe reputationally and monetarily when all of a sudden you have product recalls or escapes, as we call it in our industry, where a part out of spec gets out to the customer, and now it has to be brought back under an RMA condition and all the repercussions there. So I think that's worth talking about, that in addition to keeping the line just moving and productive, keeping it moving and productive and accurate is all part of maintenance. Is that something that drives your business as well?
Right. I think a lot of when we look at the industry as a whole, and then kind of drilling into electronics manufacturing specifically, I'd 100% agree with you, specifically where you're talking about complex product development and manufacturing, where I would actually agree with you of what you were intimating, which is it's actually probably more expensive to have a line producing, 1,000, product that ended up getting shipped versus not producing anything at all.
Right.
Is actually more
at least you're not shipping mistakes out. Right.
Yeah, exactly. And you're not having to return them and then remanufacture them and all that kind of stuff.
Yeah.
And I think what's interesting about that is that in electronics specifically, we see on that kind of maturity model that I was mentioning. So we have this maintenance and asset management maturity model. Again, 70% of everyone we talk to is in that reactive stage and trying to move into preventive. In electronics, it's actually more close to only about 40 to 50% of people are in that reactive mode. Still higher than it kind of should be based on all of the things we've just talked about. Probably about 45% are in kind of the preventative model. So at least people have worked out what they need to be doing there. But we see more and more people in what we would describe condition-based. So this is where you're using sensors and driving that data back into this model as well, that we see. So using the kind of maintenance system as a way to check on those things. You've got a lot of other things that you're using to check quality, clearly, in these kind of environments. But, are we getting vibration in our system where the cooling thing is in place? Is it impacting the soldering I can never say that word correctly, of that, because we got
Well,
some things
you like
that
to
are
say
out.
soldering, right?
I do. That's why I've got to kick in with my
No,
UK.
I think that's more the proper way. I think Americans have flattened that word out a little bit. Soldering.
I think you might be right.
Yeah.
Might be right. I am still self-conscious about certain words, and that's one of them that I always get wrong in front of people.
Well, you should put that on your schedule to fix. There's another one. Just take that back to your laboratory.
It's our language. You guys are just borrowing it, I think.
Yeah, exactly.
But I think this condition base where we're bringing in, sensor data alongside this maintenance data, and then that can be utilized as part of whatever quality control systems that are in place, becomes really important. It's interesting. We just launched a new partnership with an organization called VibeCloud, who take all their sensors around heat and vibration and those types of things that are going to be part of these pieces of equipment that we're doing the manufacturing, and push that into their maintenance system. So we can automatically generate a work order when something goes out of tolerance. So, if you've got something that's being heated and the temperature sensor picks up that is going out of tolerance and where it should be, that can generate a work order, a maintenance tech can then take care of to get ahead of producing a load of things that might be poor quality. And so that makes a big difference in terms of that, because we see more and more of these organizations moving into that conditional based stage of the maturity model, specifically in electronics manufacturing.
It's real easy to think of maintenance as an autonomous department within a company that's this island, and they have one job. Yeah. But how important is cross-functional alignment between maintenance, engineering, and operations when it comes to uptime and reliability and all the factors?
I think the number one thing I see in manufacturing, and specifically electronics manufacturing, is the alignment between the maintenance team and the reliability engineers. Where because both of those groups are working strongly to make sure that the production line is up and producing quality product. Like, that's ultimately what they're really focused on. And by having those, if I go back to my kind of opening thesis that, most organizations don't really have a reliability engineering challenge if they have those people in place. They have maintenance, execution, and data challenge. Mm-hmm. And so those two organizations working very tightly together and understanding what they're seeing in terms of medium or long-term trends for components, for pieces of equipment. That's been one of the big things. And I think if I go back to, ultimately, this is all about trust and data in a lot of ways, in terms of that cross-functional things, where procurement are involved. The CFO wants to know if do we have another 6 to 9 months that we can delay this purchasing that replacement piece of equipment, or when do we need to plan that into our capital expenditure budget? That's really where a lot of this kind of cross-functional work comes in. Is when you have that data being captured consistently around things, your decisions improve, priorities are clearer, execution smoother across this, and alignment becomes much easier because you're trusting the data that's in front of you.
Are you seeing any increased pressure, outside pressure, from your customers or from customers or regulatory bodies pushing companies toward better maintenance practices?
Yeah, it varies, because we do serve a lot of different industries. Mm-hmm. We see that, if you take food production, 21 CFR is a core requirement there around food safety. You have to have that really locked in. So we see a lot of that there, and we're seeing more of it coming in where things are, I guess, nationally strategic. So chip manufacturing, specific types of chip manufacturing, which still does occur in the US, but maybe more in terms of as part of a broader component. Is we're seeing a lot more focus there on it. And then the other part of this is we see a huge amount of just more generalized compliance and safety coming in. OSHA's real, and OSHA has a big impact in early organizations that you and I talk to. That's a place where we see it, but just compliance in general and safety. Outside of manufacturing is a really good example of this. We have a number of ski resort as customers. You think about their asset hierarchy, like a ski lift,
Yeah.
and all of the components that are involved there, and all of the sensors that they have attached to those things, and everything else. That's a highly audited and compliance-based environment, and so we see a lot of data needing to be produced there. And again, it's not that people can't meet those requirements without a system like ours or taking the approach that we're talking about here. People get the work done. It's just that they're not spending 3 days trying to pull that data together.
Right.
That's the difference.
And back in the day before we were all here, people have been doing maintenance since the beginning of the machine age. Although the level of complexity is a different scale today, right? So
That's right.
old legacy systems, while they were effective in the day, would not be effective on today's sophisticated machines. In our industry, the phrase we coined is Industry 4.0, which I think other industries have adopted that philosophy, is where everything is talking to everything. It's a different game today. The level of maintenance required is far more sophisticated and
That's right.
and proactive than it would have been, back when we were building steam trains, and things like that.
That's right. Yeah.
So,
But I think the other part of that is that we're also, if I take a more optimistic perspective on this, is like there's also just opportunities to do that much more easily than there was before as well.
absolutely.
I think I was thinking about we had a customer who was talking to us about they're using as I mentioned, like we've got mobile phone app that is the core thing for the technicians, and how do you bring in all of those assets in that highly complex environment and be able to deal with them? And some of those are very new modern pieces of equipment, but some of them are old. Like we have curing ovens that are 15, 20 years old that have never got into a system. They've never been added. And so we use we added some AI capability where you could take a picture of the kind of manufacturer's information on the side of the piece of equipment, and automatically that would recognize it, use AI to understand what it was, and add it to your asset hierarchy.
Yeah.
So I think there is while it is more complex and more sophisticated, and we have to be on top of that, some of this technology is actually allowing people to do their jobs more easily than it was before. It's not just about having a chat with AI. It's about how do we use that technology to be much more purposeful in terms of how we help the people on the front lines do those more complex things.
What are some of the common mistakes companies make when they're implementing a CMMS or digital maintenance system?
I think the number one thing goes back to the really important point you raised earlier, which was around complexity. Is that often where we see organizations fail with implementations, mostly with other people's solutions rather than ours. But when we see those solutions go wrong, it's because they've tried to do an incredibly adventurous and complex approach to roll this out. That's the number one thing I think that we see is introducing more complexity on top of things that are already complex already, and not taking that approach of let's take the core workflow, make it easier, make it more repeatable, and then kind of scale things out.
Yeah.
And I get why, because you've justified maybe a 6-figure investment into something. You need to see ROI, but then that's kind of can be a little bit of a challenge for people. So I think that's the first thing I see. And the second thing is that not prioritizing the technicians on the front line in terms of their experience and what they need to do. I see a lot of organizations building their own solutions or taking something from one of the the big ERP vendors and failing because those systems have been built top down versus bottoms up, which is kind of the approach that we want to be taking. So I think that's the other thing is that if you don't have adoption of this maintenance system by the people who do maintenance, you're dead. That process is just dead on arrival.
Now, I would imagine when you go into a client from a sales perspective, you're selling the client, but then maintenance has to buy into it. They have we have a similar struggle. and or challenge, and that is that we sell a product, we sell a piece of manufacturing equipment that is many people consider not necessary. Our equipment doesn't make anything. It just makes the customer's product more reliable. So whether they run it through this process or not is up to them. So they consider it optional. And sometimes we can convince management, yeah, this is good. It's going to make the product more reliable. They invest in it. But if the operators don't buy into it, it's never going to be successful.
That's
so
right.
I think in your world too, it's the same situation. Not only do you have to convince management that this is an ROI investment, but if it's not embraced by the people who are doing the maintenance, it's going to be a failed project. So you really have to get all the stakeholders in agreement. And that's probably a little bit of a challenge because you've got all sorts of different mindsets. We've got the we've always done it this way mindset. We've got the we got to squeeze every dollar out of this investment mindset, and they're coming from different camps, but they're all important factors.
That's right. It's a really interesting. One of the reasons I actually love working in this industry is that we get to do both. I get to talk about, this kind of conversation where we're talking to a CFO or a plant manager about, production uptime and their impact there, and, helping them to understand the impact of what not having something like this in place can be.
Yeah.
But I think I go back to our mission. Like, our company mission is to empower the humans who keep the world's assets running. And so that forces us to be very thoughtful about those end users, those technicians, and ensuring that they have a big impact. It's funny. I was on a podcast with one of our customers earlier in the week, and his experience was really fascinating because he went from kind of rolling this out in one plant to now being responsible for 5-6 plants rolling those out. So he's having to go through that process of convincing the guy who's done all things. But the thing he described, which was just wonderful, was he's now the Limble guy, and people thank him because they felt that experience of like, oh, this is so much easier than what we were doing before.
Wow.
I'm getting ahead of work. And so that's why that kind of like the humans who keep the world's assets running is just core to how we have to think about it. Because if we were, if I just worked for an ERP vendor, we'd be ramming this down people's throats, and that's not how you succeed.
Well, then you don't get ultimate buy-in. That we discovered that as well.
Right.
If we force, management forced their people to use it, if we didn't show up in factory and embrace those people and convince them that this is not your enemy. This is actually in the long run going to make your job better. It was never a successful install. It would always, we'd fight it the whole way. So for companies just beginning to modernize, someone's watching the show or listening to the show and they're like, they're talking to us. We got to do something. Where should they start? How do they seek out the appropriate company to work with? What should they be looking for when choosing a strategy?
It's a really good question.
I guess one thing is pick up the phone and call Limble. Okay, all right. That's check that off the list. But how do they vet companies? What would you look for?
Well, I think that the starting point for this is actually even before you're talking about which technology vendor to purchase. There's what do we want to achieve with this? So, okay, like how do we go and capture the work for a specific set of maintenance processes, what we're doing? Do we know what our impact of not having something in place is? Like going to the front lines, understanding where that requirement is for how do we deliver a consistent process? Like what's getting in the way there? Because I think before you even get to which vendor, there's just this, okay, what do we actually need to do to simplify this, make it real, make it consistent? What knowledge, what information do we need to capture? And I don't think you need to do that. And most of these organizations know that they have a problem here. like if I'm talking to a large number of manufacturers who are using pen and paper and spreadsheets, it's not like those people don't know that that's a challenge,
Right.
and they don't know that thing. It's like nobody wants to be there. That's not anybody's happy place. But it's about like, okay, so what do we do to capture all of that? What do we get to? And then it's kind of like that ease of use, establishing how easy we need to make this for our persona, our technicians, to use this, because if they don't use it, as we talked about, the data doesn't get in. We can't make these broader decisions. We can't drive reliability. So I think that's the first thing is like, okay, how do we get this to make sure that we can do our processes and we can get there while being open to change? Because I think that's where we have a lot of evangelism that happens within our prospects to get to the stage where they're talking to us.
Yeah.
So I think a lot of it's about the pre-work, as it were, before you go out and do these things, and not getting kind of wrapped up into a massive software purchasing process. It's about consistency of like, what process do we want to place? What do we want to go do there? And then then it becomes, can that vendor support me? Can that vendor support me in terms of the asset hierarchy I need? I've got a very simple asset hierarchy to be successful. I can go with this vendor. They only provide that. But if I need a flexible one that's larger and encapsulate these things, I need to go look at a different vendor. So it's really about understanding the processes and the kind of the data hierarchy that you want to have internally.
Excellent. Well, for my viewers or listeners who find this fascinating, who want to reach out and get more information on just the process or the company or the strategy behind all this, if you're watching this on YouTube, just look down here where it says see more, and information on how to get in touch with Limble will be there. If you're listening to this on your favorite podcast app, when you're off the treadmill, when you're off your jogging exercise, when you're out of the car, look at that podcast app and that information will be there as well. Paul Ross, Limble, thank you so much for being my guest today. It's been a fascinating conversation on something that when you're deep in manufacturing, this is an often overlooked someone else's problem type of situation. And it's good for the viewers and listeners of the show who are in manufacturing, trying to just keep parts going out the door. It's good to kind of pull the curtain back and see what's going on the other side of that curtain to keep those machines running properly and reliably and accurately. So thanks for shedding some light on that. And it is so important. I think the tolerance for accuracy is so fine today that, compared to before, the older days, and the threshold for building profitable products in the electronics industry is changed radically. It's a cutthroat, low margin, high volume industry, not a lot of room for error. And it really begins with equipment that's working properly and a mentality and a mindset to keep it that way, preemptively, not reactively. So thanks for doing what you do. Thanks for sharing your expertise with me and my audience. And I wish you and Limble continued success in your endeavors to make the world work better. Thank you.
I appreciate it, Mike. Thanks. I think this is just a huge opportunity, and I'm just really excited about talking about it. So again, thanks for giving me the opportunity to talk to your audience.
My pleasure. All right, here are some final thoughts. As we wrap up today's conversation, one thing becomes very clear. Reliability is not an accident. It's the direct result of intentional, disciplined maintenance practices supported by the right systems and the right mindset. Too often, maintenance is treated as a necessary expense rather than a strategic investment. But as Paul shared today, that mindset comes at a cost. Unplanned downtime, reduced product quality, missed delivery commitments, and in some cases, complete system failure. The organizations that get this right understand something fundamental. Every asset, every process, and every piece of equipment is either moving you toward reliability or away from it. There's no neutral position. And in today's environment where margins are tight and expectations are high, the difference between reactive and proactive maintenance is often the difference between leading the market and falling behind. So the question is not whether you can afford to invest in modern maintenance practices. The real question is, can you afford not to? And that's a wrap on another episode of Reliability Matters. Thanks for hanging out, whether you listened on your favorite podcast app or watched on YouTube. I really appreciate you being here. If you haven't already, hit that subscribe button so you don't miss future episodes. On YouTube, consider giving us a thumbs up and subscribe. Those 2 simple clicks really help us expand our reach. And a big thanks to PCB Chat from the Printed Circuit Engineering Association at PCBchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Got a question or an idea for a future episode? We'd love to hear from you. Visit reliabilitymatterspodcast.com to apply or recommend a guest. Thanks again for being here. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the 2nd and 4th Tuesday of each month for new episodes of Reliability Matters.